Hey guys, welcome back to Iyanla Empowers. In today's video, we will be talking about types of rocks and the rock cycle. It promises to be an engaging and fun lesson. I'm really excited to speak on this topic. Before we get into the video though, please remember to like, share and subscribe. We're on the road to 1,000 subscribers and I cannot get there without your help. Please share and ask your families and friends to subscribe to this channel if they want more geography videos. Okay, now let's get into it. Now, there are three main types of rocks. So I know a lot of us always see rocks on the road, or probably if we're going to the airport, we always see these big giant boulders and we're like, rocks are rocks, but some of us may not know that there are different types of rocks, right? So there are three main types of rocks. The first one is sedimentary, second metamorphic, and third igneous. All right, it doesn't come in a specific number, it's just how it is on the slide that I'm speaking. So we have number one as being sedimentary, and I have a picture of the type of rock there. It might be a little bit small, don't worry, you will see more different types of different types of rock. Yeah, you'll see examples of the different types of rock soon, but these are some small pictures. You can always Google and look at different pictures that are there. Metamorphic, if we see it, gives you that old layered kind of look. It's a layered type of rock. And we have igneous, which is kind of a little more, it has small holes, and sometimes the rocks can be distinctive, sometimes they can look similar. We'll speak more on it. So let's talk about the first type of rock that we have here, which is sedimentary. Now, what are sedimentary rocks? Well, these are types of rocks that are formed by the accumulation or deposition of mineral or organic particles at the Earth's surface, followed by cementation. So it's simple, it's the accumulation of minerals or the deposition of minerals. So they're accumulating, and when they cement together, we have sedimentary rocks. Now, sedimentation is the collective name for the processes that cause these particles to settle in place. So to have these particles in place and to accumulate or deposit in a place is called sedimentation, right? Now, when they cement together, we have this rock. So if you look to the right, well, it's my right, we see a picture that I found on Google of just some minerals that are accumulating right here. So I don't know where exactly this is, but we can see where there's an accumulation of some mineral deposits, of course, dirt and stuff like that as well. Just to get a picture of how accumulation or deposition works. Now, how are the sedimentary rocks formed? Well, it's kind of explanatory in the definition. It says sedimentary rocks are formed from pre-existing rocks or pieces of once living organisms. They form deposits that accumulate on the Earth's surface. Sedimentary rocks often have distinctive layering or bedding. Now, sedimentary rocks, in addition to accumulation of minerals, there are also accumulation of other types of rocks and also once living organisms, so the fossils of living organisms. So we can expect to see fossils and probably teeth or something to suggest that there were once living organisms in this area in the rock. So it's often known as layering rock or bedding rock because there's so many different layers to it, right? Now, what about some types of sedimentary rock? So there isn't just one rock and it's called sedimentary. We have different types. It says common sedimentary rocks include sandstone, limestone, and shale. These rocks often start as sediments carried in rivers and deposited in lakes and oceans. Same accumulation and deposition that we spoke about earlier. When they are buried, the sediments lose water and become cemented to form the rock. So the cementation, similar to that of cement, it just hardens and it forms this rock. Now, if you look to the bottom, we have two images. The first image is a picture of sandstone and the second is a picture of shale, and these are just give you some visual on how the rocks look and stuff like that. Now I'm just going to talk about the use of one of the type. you can always go on a research adventure and look at the different uses for the different types of rocks. But I'm going to speak on sandstone. Well, the use of sandstone. Sandstone was a popular building material from ancient times. It is relatively soft, and making it being soft makes it easier to carve, right? It has been widely used around the world in constructing temples, homes, and other buildings. It has also been used for artistic purposes to create ornamental fountains and statues. Now, if you look to the right, you'll see a picture of, I'm not sure what this is. It's like a little small wall, probably for a garden or something like that. And the material that was used to make this is sandstone. All right, so if you see something like this around, or if you see something that you think may be made of sandstone, you can always post a picture, send a picture to my DM at Iyanla Empowers on Instagram, and we can confirm it, or we can talk more on this type of material or this building, infrastructure, or whatever the case is. I love to start conversations. Now, metamorphic rocks. Well, metamorphic rocks are rocks that were once igneous or sedimentary rocks, but they have been changed or metamorphized as a result of intense heat. Okay, so these rocks were either once igneous rocks, which we will speak on soon, or they were sedimentary rocks, but they changed, their composition changed, and it changed as a result of intense heat. How are they formed? Well, metamorphic rocks arise from the transformation of existing rock to a new type of rock in a process called metamorphism. The original rock is subjected to temperatures greater than 150 to 200 degrees Celsius and often elevated pressure, which causes profound physical or chemical changes. Now, these rocks were there and they were just chilling, minding their own business. Then this heat came in, this intense heat came in, so they're subjected to high temperatures, usually ranging between 150, 200 and greater degrees Celsius. And because of this temperature, it causes a change both physically and chemically in the rock. And these rocks are now known as metamorphic rocks. So if you were once sedimentary or igneous, but you were subjected to these high temperatures, your composition changes and you're now a metamorphic rock. All right, so that's the little process behind a metamorphic rock. Now, you have different types of metamorphic rock, of course. Common metamorphic rocks include phyllite, schist, gneiss, quartzite, and marble. Now, if I'm mispronouncing some of these, please don't penalize me, but I'm trying to pronounce them as best as possible. Now, we have two pictures of two types of rocks here. So we have a picture of, I'm going to say it's gneiss, and the G is silent, and you have quartzite, right? And if we get a good look at the gneiss rock, we see how it is kind of giving us layers. You can see where it has undergone some changes. We can see it in the different color and composition and the pattern that we see in the rock, right? We also have the quartzite, which looks totally different, but they were both subjected to high temperatures, probably some pressure. They both underwent some changes. So let's see which rock we're going to talk about. So let's talk about quartzite. All right, so the use of quartzite is a decorative stone that is used for kitchen countertops, to cover walls, as roofing tiles, in flooring, and for stair steps. Now, quartzite is extremely popular due to its marble-like appearance and granite-like properties, which makes it an ideal choice to be used in kitchens. And I'm going to bet that some of you who are listening to this video right now may have a countertop or some tiles that were made out of quartzite and you may not know. So you can always do some investigations to see. That would be really cool. It's very common in kitchens and tiles in bathrooms, stuff like that. There are also other types of metamorphic rocks like marble that we really know. It's very common. You can also do some investigation where that is concerned. We also have marble countertops and marble tiles. So we can see where a lot of it is used in the household. Now, finally, we're going to talk about igneous rocks. And igneous rocks are rocks that come from melted rock material or magma that lies beneath Earth's surface. Now, some persons can mix up metamorphic and igneous rocks, but they are different. Igneous rocks come from magma that lies beneath the Earth's surface. Metamorphic rocks were once sedimentary or igneous rocks that were exposed to high temperatures and changed. Now, how are igneous rocks formed? Well, the rock is formed through the cooling and solidification of magma or lava. The magma can be derived from partial melts of existing rock in either a planet's mantle or crust. So, when a rock cools, becomes solid, then it forms a pattern. So igneous rocks are kind of an ongoing pattern. So it cools and becomes solid, then it's now melted, then it cools and it becomes solid, and we're therefore getting a lot of layers. And basically this is how the rocks are formed. So when magma is cooled, solidified, we have igneous rocks. Can melting occur again? Yes. Cools and solidifies, and it keeps on going. Alright, so igneous rocks are divided into two groups, intrusive or extrusive, depending upon where the molten rock solidifies. And we're going to speak on the different types of igneous rocks. So the first one is intrusive. Now, intrusive or plutonic igneous rocks forms when magma is trapped deep inside the earth. As the name suggests, intrusive, inside, right? Now, great globs of molten rock rise towards the surface. Some of the magma may feed volcanoes on the Earth's surface, but most remain trapped below, where it cools very slowly over many thousands or millions of years until it solidifies. Slow cooling means the individual mineral grains have a very long time to grow, so they grow to a relatively large size. Intrusive rocks have a coarse-grained texture. So these are rocks that are cooling very slowly, thousands or millions of years. Because they're cooling so slowly, the individual mineral grains have a very long time to grow. Alright, so they're usually very large. Now, some examples of intrusive igneous rocks are diabase, diorite, gabbro, granite, pegmatite, and peridotite. Okay, don't quote me on those, right? But one should stand out to us, and it's granite. We really know granite is a very famous rock. I have a picture there. A lot of us are very used to it, so that's why I'm going to speak on the use of granite. Now, don't be afraid to pause the video, look at the information, kind of run through it, make some notes, just in case you probably want, a slow understanding. You just take your time and you read the material. It is there. Now, the use of granite. Now, granite is used in buildings, bridges, paving, monuments, and many other exterior projects. Indoors, polished granite slabs and tiles are used in countertops, tile floors, stair treads, and many other design elements. Now, granite is a prestige material used in projects to produce impressions of elegance and quality. And a lot of persons probably have some granite countertops in their homes as well. It's very common. It does project the idea that there's some sort of elegance and quality in the home. That's why a lot of persons opt to get granite countertops or granite tiles, and stuff like that. If you look at the picture right here, we see this entire countertop is made of granite and it's very pretty. It looks really good, really nice. It has an elegant feel, so we can see why a lot of persons like it. Now, on to extrusive igneous rocks. Well, these igneous rocks are produced when magma exits and cools above or near the Earth's surface. Extrusive, we're thinking now outside, right? Now, these are the rocks that form at erupting volcanoes and oozing fissures. The magma, called lava, when molten rock erupts on the surface, cools and solidifies almost instantly when it is exposed to the relatively cool temperatures of the atmosphere. Quick cooling means that mineral crystals don't have much time to grow. So these rocks, have a very fine-grained or even glassy texture. Hot gas bubbles are often trapped in the quenched lava, forming a bubbly, vascular texture. Now, we can point out a main difference already. Well, two actually. Intrusive occurs in the inner earth, extrusive outside near the earth's surface or on or above the earth's surface. Also, the time in which they cool. Notice extrusive rocks, they are on the surface, above the surface. Same thing for me, but above the surface is the correct preposition. And because they're exposed to this air, they cool almost instantaneously, versus the ones that are found in the inner Earth's surface. They cool over thousands or millions of years, right? So we spot some differences already. Here we can see why they have two different categories. Now, these rocks include basalt, dacite, obsidian, pumice, rhyolite, sora, and tuff. Some of these really stand out to me, like basalt, obsidian, pumice, rhyolite. I have a picture of basalt right here. Also, we get the idea that most extrusive igneous rocks are going to be a bit holy because of the hot gas bubbles, right? Now, the uses of basalt. Basalt is used in construction, example as building blocks or in the groundwork, making cobblestones from listen, I don't know what's wrong with my pronunciation today. Columnar basalt, from columnar basalt. Why was that so hard for me? It happens to the best of us, alright? And in making statues, heating and extruding basalt yields stone walls, and which has the potential to be an excellent thermal insulator. This picture right here is a picture of pavement that was made using basalt. Now we're gonna review a bit, alright? So you can always go back, watch back the video, understand it a bit more, slow it down, speed it up, however you learn. I have the information there for our visual learners, and you have me talking for your audio learners. So it's all here, right? Now let's review. Number one, we have some questions here. When rocks are affected by weathering and erosion, they change into which of the following? Alright, I want to give you some time. Think about the answer based on what we just went through. We're going to try to put this rock cycle together. Alright? Now, when rocks are affected by weathering, erosion, some words that can probably jog your memory: accumulation, deposition, cementation, they change into which of the following? So that's number one. Alright, so let's give you guys 30 seconds. Okay, you guys can just pause the video. Alright, let's move on. If you said sediment, you are correct. Now, when rocks are affected by weathering and erosion, they change into sediment. Alright, and we can see that the weathering and erosion part was filled out for us, and the sediment part was filled out for us. Good. Now, number two is when sediment is compacted and cemented, it changes into which of the following? Alright, so you can just pause the video, think about it, select the answer before I state the correct answer. Okay, did you think about it? Alright, if you said sedimentary rock, you are correct. You have been learning. Love that. Let's go to question number 3. Now, when heat and pressure are applied to a sedimentary rock, it changes into which of the following? Remember when we talk about those rocks that were subjected to high temperatures, sometimes pressure changes physically, chemically, What type of rocks are those? Alright, have you thought about it? Well, if you said metamorphic rock, you are correct. Metamorphic rocks are subjected to heat and pressure. Question number 4. When melting of a metamorphic rock occurs, it changes into which of the following? So you can look at the picture that's being, kind of completed as we go along. So we have weathering, erosion, sediment, compacting, and cementing. We have sedimentary. When melting of a metamorphic rock occurs, it changes into which of the following? Have you thought about it? If you said magma, you are correct. So when the metamorphic rock melts, changes to magma. And question number 5, or final question, when magma is cool, it changes into which of the following? Remember when we talk about magma? Above the earth's surface, beneath the earth's surface, we have 2 types of this type of rock. If you said igneous rocks, you are correct. Let's see what we created. So we have created the rock cycle. As simple as that. We have created the rock cycle. Now let's start from metamorphic rock. Metamorphic rock subjected to melting. Melting, it turns into magma. Magma cools, it turns into igneous rocks. When igneous rocks melts, it turns back to magma. We have igneous rocks are subjected to heat and pressure. Heat and pressure gives you metamorphic rock. Metamorphic rock can weather and erode. Igneous rocks can weather and erode. Forms us some sediment. This sediment can be compacted and cemented, which forms us our sedimentary rock. Sedimentary rock can also weather and erode, forming sediment as well, also being compacted and cemented. Then we have our sedimentary rock, subjected to heat and pressure, can give us our metamorphic rock. And that is our rock cycle. So it's a process, it keeps on going. And we need the help of the different types of rock to get it going and pumping. If we take out sedimentary rocks, it could work, of course. But, what would the cycle be without sedimentary rocks? We need all our type of rocks involved. And that is our rock cycle. Similar to any other cycle, or water cycle, or carbon cycle, nitrogen cycle. It's right there. And from, the basis of what happens to each rock, you will be good. You can always use these 5 questions as a guide to understand exactly what happens, and you're going to realize that it's going to be very easy breezy for you as soon as you start to just get it down on paper. I also have a did you know here. It says, did you know 2/3 of the area of Jamaica, which is 70%, are covered by cave-riddled limestone and are deposited on top of older igneous, metamorphic, and clastic sedimentary rocks. Did you know that? Basically, it's saying 70% of Jamaica is covered in limestone. Alright, and that is 2/3 of the area of Jamaica. That's a fascinating fact. I'm pretty sure a lot of us did not know that. Now you know because you watched this video. And that brings us to the end of the video. I really hope you enjoyed it. Thank you so much for watching. Please remember to subscribe, leave your questions below, or if you want to make it a bit more private, you can always leave your questions in my direct message DM on Instagram at Iyanla Empowers. Thank you so much again for watching. I really appreciate you guys. See you guys in the next video. Bye.